We present Synergizing Unsupervised Episode Detection with LLMs for large-scale news events. In the age of real-time news, keeping up with ongoing key events has become increasingly difficult. With dozens of articles covering the same story, readers struggle to piece together a coherent and complete understanding of an event. Traditional event structures can be visualized as a hierarchy, going from themes to key events, each covering 1 to 2 days, further divided into episodes, and finally into individual atomic actions. Existing automatic event detection techniques often fall short. They're either too coarse, like document-level clustering, or too fine, like phrase-level action chains. Episodes, unlike the other levels of granularity, are the sweet spot, more interpretable than fine-grained action chains, yet more informative than high-level document clusters. But detecting them is a challenging task. We introduce EpiMine, a framework for unsupervised episode detection that synergizes structured event signal extraction with the deeper reasoning capabilities of LLMs. The first challenge that we run into are that episodes aren't typically associated with timestamps. Unlike key events that align with article dates, episodes occur within articles and lack clear temporal markers. However, journalists tend to naturally partition their articles by episode, writing about one cohesive development before moving on to the next. The second challenge is that episodes are semantically diverse. Actions within an episode may look very different. These actions describe the same protest, but share little semantic similarity, so we can't cluster episodes using traditional similarity methods. Instead, EpiMine detects shifts in discriminative term co-occurrence, which means identifying when a cluster of salient terms, which consistently co-occur, shifts to now a new cluster of terms, signaling a potential episode boundary. The final challenge is that articles only cover partial events. Each news article is incomplete. No single document typically covers all the episodes, especially as they are currently evolving. To compensate, EpiMine selects a subset of high-quality articles, then merges overlapping episode fragments across those articles to reconstruct full episodes. We outline 4 core stages of EpiMine. First, we begin with episode indicative term mining. We look for pairs of words that frequently appear together within the same segments of a news article, but not across different parts. These are what we call discriminative term pairs. For example, barrier and shoved might co-occur in descriptions of protesters storming a building, while spray painted and podium show up in a different scene entirely. Next, we move on to episode partitioning. Here, we use those discriminative terms to divide each article into smaller, episode-like sections. If the key terms across consecutive segments do not tend to discriminatively co-occur, that signals a shift in topic and likely a new episode. This lets us extract natural episode boundaries and form episode fragments, even without clear timestamps. Third, we perform LLM-enhanced episode estimation. We only use a few high-quality articles for this step. We rank the articles based on the quantity and quality of episode fragments contained within them. Now that we've partitioned the articles, we cluster similar segments from different articles together. We then use a language model to summarize each group into a clean, readable episode, describing who was involved, what happened, and where it took place. Finally, we have episode segment classification. With our main episodes identified, we go back to the rest of the corpus and pull in any leftover segments that match these episodes. We check if they contain similar terms or describe the same scene, and if so, we assign them to the right episode. This helps us build a complete picture of each episode, even across scattered and partial coverage. To evaluate EpiMine, we created 3 new datasets spanning 30 key events, including political events, terrorism, and natural disasters, each annotated at the episode level. We measure performance using 3 quantitative metrics, adapted for episode detection. Of Of the model's top K segments per episode, how many align with a true episode? For each gold episode, is there at least one predicted cluster that captures it? And finally, the harmonic mean of the two. Across all domains, EpiMine outperforms all baselines, with an average 80.8% gain in K precision, 34% gain in K recall, and 62.8% gain in KF1 over existing methods. Even when compared to models like K-means that are given the ground truth number of episodes, EpiMine demonstrates superior episode-level precision and recall. So what drives this performance? First, EpiMine's episode fragment clusters are key. LLMs alone, or poor quality clusters from our baselines, often fail to detect meaningful episodes. But when provided with EpiMine's high-quality fragments, the LLM is suddenly able to identify distinct, well-formed episodes with rich temporal and semantic detail. This is confirmed by our no LLM appellation. Even without language model summaries, EpiMine's clusters significantly outperform all other methods. Second, our novel discriminative co-occurrence measure captures episode context beyond surface-level semantics. While cosine similarity finds synonyms like stormed and ransacked, our approach also identifies key surrounding elements, like slogans, walls, and flags, that define a specific episode. When we remove this component, our performance drops across most domains, highlighting its value in distinguishing episodes with diverse action types. Third, EpiMine's article ranking strategy plays a major role. By selecting the top 25% of articles based on both the quantity and quality of episode fragments, EpiMine captures nearly all ground truth episodes, while reducing context length and minimizing noise. This enables more efficient and focused LLM reasoning. Furthermore, we conduct a qualitative case study. We do this on the 2019 Hong Kong legislative protest, where we compared EpiMine to the other models. Baselines either produced generic, repetitive episodes or missed key ones altogether. In contrast, EpiMine detected more fine-grained episodes with accurate entities, actions, timestamps, and locations. Even EpiMine's incorrect episodes turned out to be important sub-events discussed across multiple sources. Lastly, our confidence mechanism refines the final episode clusters, helping EpiMine avoid misclassifying segments that are ambiguous or overlap multiple episodes. While removing confidence may boost recall slightly, it comes at the cost of precision, making this a useful knob depending on the use case. Altogether, these results show that EpiMine delivers high precision, interpretable, and scalable episode detection, not just outperforming existing systems, but enabling a deeper, more structured understanding of evolving key events. Please check out our paper and our code if you are interested, and reach out if you have any questions or are interested in collaborating. Thank you.